Okay, question number 4. Consider m of x, which is 5 on x. So we have a hyperbola. Let R represent the area trapped between m and of x and the lines x equals 2 and x equals 4. So that's going to be from 2 to 4 of 5 on x dx, which is exactly what we've got there. And that's going to equal integral from 2 to 4 of 5 divided by x dx. And that's where I get 5 log base e of 2 square units, and that's what R equals. Okay, so let S represent the area trapped between the lines 3 and 6. So again, we're now going from 3 to 6, and that's area S. So if I change that to 3 and that to 6, and I press X here, I get the same answer. So it's equal to 5 root 2, so S equals R, because I'm going to give it in terms of R. So what's the next bit? The next bit is from 1/3 to 2/3. So from 1/3 to 2/3. And lo and behold, I get the same answer. So T is also equal to, and that means that T equals R is the right answer. So if I'm going from 1/3 to 2/3, it's the same. Now, 2 to 4 is double, 3 to 6 is double, 1/3 to 2/3 is double. So let's test this and put 5 and 10. And I get the same answer. 50 to 100. And I get 5 log base e of 2. Okay, so give two different definite integrals, make up two new definite integrals where this upper terminal and lower terminal is a multiplier by 2. So I've chosen 7 and 14 and 5 and 10. You can choose any, but they've got to be different to the ones that have already been shown above. And then lastly, sketch a graph. I chose between 4 to 8. You could choose something that's different to 5 to 10, 7 to 14, 1/3, 2/3, 3 and 6, and 2 and 4. Okay, so over the page we now have these lines, and I've been asked to work out L1, which goes from the origin to point A, and point A will be, remembering, m of x equals 5 on x. So at 2, that's going to be 5 on 2. And I'm using from my bound book y minus y1 equals y2 minus y1 over x2 minus x1, x minus x1, where 0, 0 is my x1, y1, and 2, 5 on 2 is my x2, y2. And that's what it looks like, and I just typed that in the calculator. Y minus 0, you could avoid the y minus 0 if you wanted, fraction 5 divided by 2 minus 0 over 2 minus 0, and then bracket x minus 0, and press X, and I get y equals 5 on 4x. And there it is, y equals 5 on 4x. Then going from this point to find L2, I'm going to say that this point here is 4 and 5 on 4. So I've now got this expression. So just going back up here, grab that, put it into a new line, 5 on 4, and that's 4. Press X here, and I get 5x on 16 as being the second equation. And then lastly, write two definite integrals that represent the area trapped between L1, L2, and m of x. We're looking at this yellow section. I need to consider one definite integral for this area, where my top curve is L1 and my bottom curve is L2, and another definite integral for this one, where my top is m of x and my bottom is L2. and you're allowed to use L1 and L2 and m of x and L2 in the notation. And when I put that on the calculator, lo and behold, I get 5 log e of 2. So this area is also equal to r, because you've got to give it in terms of r. And that's how the last question went.